maybe because of thunderstorms later today.
Maybe,
Can't come here for me, maybe.
maybe. Oh, it always gets me a bit concerned that people start coming because the class is flipped, so, but I also understand that because of COVID. All right, so let's talk about, so I just want to briefly talk about the quiz, and not the quiz, the exam. All right, I sent out a link to the practice exam via, you should have gotten it via email, your email. So just, if you can't find it, click on the announcements, click on the announcement that says practice exam and download it, or you can find it under files because that's there. Also with a bunch of slides for the textbook. Don't know why I didn't bring that up earlier. So not that I use those slides for or the textbook, they just get transferred over every time I import the class. All right, so this exam, like I said, is much longer and much more difficult than the exam on than your actual exam. I used to do 100, 105 points on it, just as opposed to 100. Don't worry about that. Your regular exam will be out of 100. And this was, the idea here is that this would be a closed book. Sorry, this practice exam was a closed book as opposed to your actual exam, which will be open book, open note. So just keep that in mind as well. Also note that there are no intentional errors in the code that I give you unless I explicitly say, hey, there's an intentional error here, So if you think something is wrong, if you see something, say something. If you, I should probably reinstitute a policy of bug hunting in my code, which is that you get a point on the exam if you find a bug in this code. So, so first things first. So these questions over here, which I'm going to go over these questions next Thursday in like the answers and do them. These questions over here, this first section deals with basically adding and removing from a linked list. And basically drawing and showing what will happen. So on the exam, I'll be asking you to draw something because that helps me understand that you understand how to do this stuff in theory. Now, but the exam's electronic. How the world do you do that? File upload. That's how you do it. So yes, you do have permissions to pull out your phone and take a picture of something you draw, or to draw on your computer, depending on what you do, right? So just a lot of leeway on how you want to do that one. You can draw it on the computer, you can draw it by hand. I highly recommend drawing it by hand. And then if you can't upload it, just hand it into the TA and make it their problem. Okay. But here, right, I'm going to be concerned more about drawing than the actual commands, because again, part of the practice exam is that it is supposed to be practice. So I've given a lot more questions. The exam is only 7 questions long. I think at least, unless I go and change it, it's only going to be 7 questions long. So because I found that so it's this weird thing that you may not understand until you experience it and sit down on an electronic exam where you're allowed to use your IDE. You code faster on paper because you don't have syntax errors on paper, or rather, you don't have syntax errors you care about on paper, right? There's no mistyping, right? Where you maybe instead of doing paper, you do pater, right? There's no mistyping when you're writing something. And no having to backtrack for that. There's no syntax errors if you forget to put parentheses. If you forget to do closing curly brace, right? And so you aren't looking through your code to try to sort through that, right? But your code, when you're when you're doing your exam, you're like, oh God, it's got to be 100% exactly correct so that it will run, even though I don't really have test cases for it. So I would like to draw your attention again to this topmost portion. Your written code does not have to be 100% syntactically correct. If you have a basic syntax error, the most you'll lose is a point or two on a question, right? We're talking, okay, so, and that depends on the severity of the error. I rarely take off more than 1.4 for that, because like in a 10-point question, I try to grade each question like it is a exam on its, like a sub-exam on its own. So I say, okay, yeah, this is a minor mistake, but it's still an A answer, so only 1 point off, because that's 9 out of 10 is an A, right? So using a node with, so basically, so that's why the exam is shorter on paper, because it does take longer, because there's just extra overhead. And then Murphy's Law. There is not really much Murphy's Law when there's paper and pencil involved, except for your pencil breaking or your pen running out of ink, which is easily solved by raising your hand and saying, hey, I need some, so there's, so, but on computers, they're just waiting for the right moment to mess your life up. So, keep that in mind. Now, if you need extra time on the exam because of DRS accommodations or something, email me so that we can figure out the best way to do that, because sitting in the lab doesn't really work anymore, because as soon as the 2-hour period is up, they'll want to move you somewhere else, and then what, you want to bundle into an office in close proximity with the TA? That doesn't sound very COVID safe. So send me an email and we'll figure something out, okay? Likewise, if basically you find you go over time, send me an email and we'll figure something out, okay? Because, but you need to let me know sooner rather than later. But yeah, so, oh, I should have been recording this. Wait, no, I am recording this. Awesome. Okay, so on the exam, there'll also be some questions about just doing list methods in general, just like you did in for your second assignment. There'll probably just be one of those questions. And an accompanying question which says, hey, that thing you just wrote, tell me what your big O time complexity is. So that's how I test you on big O time complexity, which is 2 ways. I ask you to write something in big O time complexity. And then for some of the coding questions that deal with linked lists, I will tell you, hey, there's a restriction on the time complexity. It has to be a linear time algorithm, which essentially means you're allowed 1 loop through the entire list, right? So here, linked list, you can assume that you have head, tail, and size, and all the other standard linked list methods that you have access to, unless I explicitly say otherwise. If on the other hand, that doesn't mean you're not allowed to write something, though. If I say you can't use something, that doesn't mean you can't write something, though, that replicates its function, right? Because you just wrote code, that's fine. It's your answer. But generally those restrictions are there to make you think about the correct way to do it. For the practice exam, I always do a doubly linked list, because practice exams, you don't really have a time limit, and single and doubly linked lists are more time consuming and have twice as number, but they help you think more because you have to think through twice as many things. So the exam will be singly linked unless you like pain, in which case, okay, sure. But anyway, so here, right here, I'm telling you, hey, write a method called count, right? There's probably one that's built in that does something similar. So int count item, right? Just simply tell me how many times that item appears. It's a fairly standard question to go through. Note that it's an instance method, so you have head, tail, and node class, right? So on the other hand, some questions are like this. Now, those of you have read ahead or had some more experience, you might recognize this as the merge process of merge sort, right? Write a static linked list it takes in two sorted linked lists of integers and merges them into one sorted linked list and returns it. All right. But this is cool because this can be done in linear time. It's one of those, if taking two lists and combining them into one list, that if both lists are sorted, combining them into one sorted list is a linear time process. It's really cool. And we'll be exploiting that to write merge sort later on. But here you have no need to access the head or the tail of the list other than using the get 0 and remove 0, right? And the add method. You really don't have, so here you're just manipulating the list like that. This one is a common interview question, right? A method that reverses a doubly linked list, except it doesn't start, they just simply say reverse a linked list, and they let you make your own assumptions, and then they start restricting the assumptions, such as, okay, use a doubly linked list. Okay, what if you don't have, what if it's a singly linked list? Okay, what if you have to do it in place? You can't use you can't use any auxiliary data structures. In other words, you can't store any nodes or items outside of the list. You have to manipulate all the pointers manually. So this gets painful, and you typically have a 45-minute kind of thing to do this, but it's a common enough interview question, or has been, because everybody knows it's an interview question, and so now it's just a practice interview question. Speaking of practice interviews, by the way, if you like practice interview, if you want to get practice interview experience done for this is a free service I used when I was starting to look for jobs and debating between going into academia or industry. And besides, it was just good experience to get. Basically, it's peer-to-peer interviews, mock interviews. The difference is that you're each given a half an hour and you're given a question, and then the answer. And then you interview the other person. So you know what the answer is, you know how the code works. The other person asks, you ask the other person their question and they ask you their question. And then they score you afterwards, basically on how you did. So it's a good service for just trying to figure out, if you just want to practice stuff. You'll find that a lot of stuff, that a number of questions that once you're done with this class, you'll find a number of questions rely on knowledge of data structures from this course. Okay. I just figured I mentioned that since I thought about it. All right. Here's another question, which creates a new type of linked list called the sorted linked list, which is a linked list, but it keeps all the items sorted. So we just had a question about a sorted link, two sorted linked lists. And now we have a question about a sorted linked list data structure. This is what we call in the business a hint. That maybe the questions that I like to ask on exams are when they concern linked lists are about sorted linked lists. So just keep that in mind. So here you're asked to do add. There is no index for this method because it's a sorted linked list. So you add the item and it's going to sort in place. You can assume that it just is going to use an integer, even though it's e item over here. So you can assume that it uses an integer for the sake of speedily coding it and use less than, greater than, or equal to. But if you use e's, you got to use compare to, which means that e has to extend comparable, right? So that's something you can do for extra credit if you remember how to do it, right? And remember, I forbid these methods. You can't do this because it doesn't make sense in this context anymore, because that would allow you to add an item anywhere, which is bad because it's a linked list. You shouldn't be able to add items anywhere. And then get node can't have that because I don't want you to use it really, because you'll immediately try thinking how to use get node to solve the problem, and get node is not an optimal solution for this problem. And when I say optimal, I want it to be in linear time. So on the exam, I'll have a point breakdown for questions like this, and having it run in linear time is a certain number of points. So if you can't figure out how to do it in linear time, you're still going to get a good amount of credit on it. right? So there's a point breakdown there, and I try to do for large problems a point breakdown so that people, similarly, hitting different conditions, like here, you got to make sure, like in this case, adding, well, right, when we're adding to a linked list, we got to care about the head and we got to care about the tail. So, and we got to care about out of bounds, but this doesn't have an out of bounds setting, right? Because it's a sorted linked list. There's no index to add, you just add it. So don't worry about that, right? Remembering to do things like incrementing the size at the end. That's worth at least a point, so my grading criteria, my grading works like this. If it's mostly right, I look for the imperfection. Sorry, if it's right, I look for the imperfections in the code or something that you missed. If it's mostly right, I look at what conditions you fulfilled and try and grade that there. If it's mostly wrong, I look for the little bits that you were able to show that you understood that you understood in some context what you were doing. It's very rare that somebody puts down an answer that isn't, that doesn't at least get half credit, because at least those items will, at least because at least when you write code, you probably are aiming in the general direction of something. The issue is when people leave stuff blank. Don't do that. And as I pointed out, one of the questions on the exam is array lists and linked lists. They have different implementations. Compare and contrast array lists to linked lists. Okay, and in what situation would you want to use a linked list over an array list and array list over a linked list? Remember that the point is, the reason we have these two lists is because they're good at whatever the other one is bad at. Right, array lists, they can do constant time looking at indexes. Linked lists can do constant time add and removal from the end. They're both terrible at adding in the middle, but you can't really get around that. Although linked lists have the advantage of is that you can manually code it so that if you go into and find a certain index that you want to insert a bunch of items in between, you can do that. Linked lists are great when you are wanting to split up a list. So any kind of thing where you're splitting it or merging it or interweaving it, linked lists are great. It's such a hassle to try to do that with array lists because in terms of runtime complexity and space complexity. It's just, but since every single list, okay, and this is where we start getting into stuff when we're talking about recursion. Every single list, every single item in a linked list is a list of size 1. It can be manipulated very easily. Just think about that for a second. Yes.
I have a question. If I have two linked lists and they're different objects, can I have the tail of list A points to the head of list B?
Not necessarily, probably not in Java, that depending on the implementation. But I would suffice to say that Java would probably be very upset with that.
Okay.
But programming, some languages that don't do generics don't really mind, like Python comes to mind. So yeah. So I will go over this again the day before the exam, but if you have any questions about these things, I am happy to answer them. Notice that there's nothing about stacks and queues on this exam. There doesn't really need to be. Stacks and queues are very useful. We utilize them a lot when we are doing graphs later on, and then also the recursion when we go over that, and that's what's going. So exam 2 is primarily over recursion and trees, and recursion implicitly uses what's called a runtime stack, which is just a kind of this built-in stack that basically helps the program keep track of where it is, that you never really see, but it's there. All right. So any questions? Yes.
You said it was easy to split a linked list.
Uh-huh.
How come? Since I still need to add them to a separate linked list.
It's easy to split a linked list in the sense that if you're manipulating things and trying to like, so say I have 3 lists and or say I have 2 lists. The first list is split up in half into A and B. Right, so I can iterate halfway through between A and B, and I can just kind of temporarily hold on to node the quote unquote head of the B half of that initial list. Then I can take the second list, connect the head and tail appropriately. And so I can just do that operation very easily without using using what's called constant extra space. So, which is one node's worth of space. And then by attaching the pointers, I don't have to create secondary lists.
Okay.
Right. I just can keep track of everything because each item is essentially holding on to the last item to make sure that it doesn't get collected by the garbage collector. It becomes very apparent when you try to do merge sort with, so with this question over here, and I'm not sharing my screen, so I'm sorry, but this question over here, the merge question. If you want to see what I mean, try doing that in constant time with, sorry, not constant time, in linear space, sorry, linear time and constant space with a array list. Just try it and you're going to bang your head against the wall. Okay, that said, array lists are kind of the default because a lot of times you want to just access stuff a lot of the time rather than playing around and manipulating stuff. For instance, the list, for instance, Python doesn't really do arrays. If you're coming from Python, you know, they call it a list because it is a list. It's an array list. So, you know, and pretty much the default list is always an array list. All right.